friction is the most fundamental force which exists at every place on earth. Now, what is friction and what is the cause? What is the orientation of this force? Let's talk about it. See, according to Newton's first law, a body continues to be in state of rest or of motion unless and until an external force is applied on it, right? So if I roll it out, suppose there is a ball in my hand, and if I roll it on the floor, the ball will cover some distance and it will come to rest. So why is it coming to rest? There is no force acting on it, but it is coming to rest. That obviously means there is some opposing force which is acting on the ball. That opposing force is called friction. We need power, we need more energy to keep running vehicles or to keep moving machinery parts. So for that we need lubricants. There are a lot of things which are involved with friction. So let's study about the cause. Friction, according to definition, friction is that force which comes into play when one body tries or actually, when one body actually moves or tries to move over another body. This is what frictional force is. So frictional force is actually like a viscous drag force. Now viscosity, that is viscous force, acts in fluid layers. For example, I have a beaker in my hand filled with water and I am stirring it, okay. When I am done stirring, if I remove the stirrer, I will see that water will gradually come to rest. Firstly, initially the lowermost layer which is in contact with the beaker will come to rest, then the upper layer, and it goes on, and ultimately the whole water will come to rest. So that is a viscous force which is a frictional force between two layers of liquid. So friction in reality it is an opposing force. Opposing means it will always opposes the motion. It is an opposing force which comes into play when one body either actually moves or tries to move over another body. So what is the cause of friction? Alright, let's discuss about cause. There is an old theory, that is, we'll discuss the old view first and why we discarded it. There was this old theory which stated that suppose these two bodies are in contact, okay. So if you enlarge this much part and if you see, then you will see that there are irregularities and projections in the bodies, alright. So they say that these projections, what happens, these projections, they get interlocked in between. So the frictional force is the force which is required to overcome the interlocking. So because interlocking, obviously suppose this red body is moving over black body and these projections are interlocked. So I would be requiring some force to push this red body above it so that it can break the interlock and move further, right? So this was an old view. So what people did, what scientists did, they smoothed both the surface, like they on molecular level they smoothed both the surface completely. So what happened, the new structure was something like this, a completely plain this body and a completely plain another body, okay. Now they brought these two bodies in contact and they tried to move one body over another body. So what happened was, when on molecular level, when these two bodies are completely smoothened and they are placed in contact, so the result was this became both the bodies actually coalesced and they form one body. So now it was impossible to move this body or this body because they actually stick to each other. So what happened, what went wrong? According to friction, the cause of friction was the interlocking between the joints, the projections. But when I joined these two bodies, after completely smoothing them, the bodies coalesced to form one body. That means frictional force increased infinite times. So where the theory is wrong was, actually the real cause, that is why the old view was discarded and we then have a modern view which says that friction is not because of the interlocking of joints or projections. Friction is because there is a contact force forming at the actual points of contact. These are two bodies and I have shown you the projections or the irregularities in the surface. So at these points of contact there forms a adhesive force of interaction, and this adhesive pressure is so strong that it sometimes melts the body, or the plastic deformation takes place, and these two body actually sticks over another body. So in order to move this body, or this body will have to break all such bonds which have already been formed, and we will require a constant force to supplement this body to keep moving, so that it will keep overcoming the other forces which are forming, right? So this is the real cause, and according to this theory, the cause of friction is the actual point of contact. At actual point of contact there is a bond formation, that is cohesive bond formation, or force of attraction gets formed, which causes the frictional force. So if I apply this theory on this, when I completely smoothen the bodies, the point of contacts were infinite, and since points of contact were infinite, so the bond was formed at every point, and that is why these two bodies stick to each other. So that is why the modern theory was taken into consideration, and this is the real cause of friction. So the final answer is, the cause of friction is that when two bodies are in contact, there is a bond formation between the actual point of contacts between the bodies, and the point of contacts are in this ratio, 1:10⁴. This is the ratio of total surface area and the actual point of contact. So this is how the number varies. So at actual points of contact the bodies forms an adhesive force, and to overcome that force and to break all such bonds we have to apply some force, which is basically the cause of frictional force. Now as I already discussed, the frictional force will be coming into play when a body moves or tries to move another body, right? So according to frictional force, this definition, we have three different kinds of frictional force. One is static friction, and other is kinetic friction. I said three, right? I'll give you the third. One is kinetic friction. Okay, so static friction is that frictional force when there is a force applied. Suppose there is this duster, okay, I am applying force on this duster right now, but the duster is not moving. So this is the force of friction which comes into play when a force is applied on a body, but the body is not moving. That is, it is trying to move, but it is not moving. So there is a statement given for frictional force which is called, friction is self-adjusting opposing force. This statement is very well valid for the frictional force. Now this statement is also self-explanatory. For example, what do you mean by self-adjusting force? The force which adjusts itself. Suppose we are talking about this body. Suppose there is this body placed on a book, placed on a table. I am applying a force of 2 newtons, but the body is still not moving. That means, according to law of motion, the body should have moved, but it is not moving. That means there is an opposing force which is acting on the body. So the opposing force, which is frictional force, is acting on the body, which is exactly of the same magnitude. That is why the body is not moving. Let us say now I am applying a force of 4 Newton and body is still not moving. So that means the frictional force is also 4 Newton. So this is the character of self-adjusting force. But there will be a limit of friction, right? There will be a point when why this force is applying and why is body not moving. Force is applied to move the body, but the body is not moving because these forces are not enough to break all the bonds which are already formed between the actual point of contacts. So to break all those bonds, we will have to apply a bit larger force depending on what type of surfaces are in contact. Okay, so suppose 6 Newton is the force at which all bonds will break. So at 6 Newton the body will start moving, right? So this is called static friction. It is the frictional force which comes into play when one body tries to move another surface but it is not actually moving. And the second part is kinetic friction. It is that part of friction which comes into play when one body is moving over another body. So what is the limit of static friction? There will be a value, right? As I said, in this case, suppose at 6 Newton the body starts moving. That means at 6 Newton all these bonds got broke up, right? And the body started moving. So this is called limiting friction, the third part. Limiting friction is the highest value of static friction, and this is sometimes also known as limit of static friction, but generally it is known as limiting friction. So we have got three types of frictional forces: static friction, when the body is not moving, it is trying to move; limiting friction, it is the highest limit of static friction after which the body will start moving; and the kinetic friction, when the body is moving. So if I draw a force between applied force and the frictional force, for example, I applied 2 newtons, frictional force was 2, I applied 4 newtons, frictional force was 4, but there will be a limit to the static friction at which the body will actually start moving. So that is called limiting friction. So this is how our graph would be. Consider the fact that initially the forces were equal, so x and y axis plot will be 45 degree, right? Because x and y axis are equal. So suppose this is our frictional, this is our applied force. Okay, let me see which part is to be taken what. Okay, I'll tell you which part is to be taken what. We have, actually I should tell you, this is frictional force. I'll denote it with small f, and the applied force. Okay, so frictional force keeps on increasing till the point the value of limit comes into play, right? And after that there is a small decrease in the value of frictional force, because this is the highest limit which was required from this part to this part. This is the highest limit which was required to break all the bonds, and after that body needs a constant, after that body will feel only a constant frictional force. So when you keep on increasing the frictional force, this is how the graph would be. Initially frictional force will increase up to the point where there is a limit. So this part is called, from here to here, this is our static friction. So I'll write it with this, and from this point onwards this is kinetic friction, and the highest limit is called coefficient of or limiting friction, right? This is the graph. What else in friction? Okay, let's deduce some formulas for static and limiting friction. So we'll start with the laws of friction.